With the worldwide push to reduce global warming, coal has received particular attention. It produces significant greenhouse emissions. Well, for decades, researchers have been working on ways to extract the energy from coal without digging it up, which will have a lower impact on the environment. There's now a booming coal gas industry, which is not only cleaner, it also allows coal seams to be tapped that are either too deep for traditional methods or too gassy. Mark Horstman returns to his home in southeast Queensland to check out this technology that's ushering in a new coal rush.
The face of the Darling Downs is changing fast as agriculture gives ground to mining. In many paddocks these days, you'll find the hard hats of the coal gas industry.
I come to work every week and there's new people I've never met before. We're growing so much, and it's genuinely an industry that's got its time and its place, and it's happening now.
What's different about Queensland's new coal rush is it's all about getting the energy out of the coal without digging it up. This is a story about using coal for gas, and two very different ways of doing it. One is UCG, or underground coal gasification. It burns the coal underground. The other is CSG, or coal seam gas. It keeps the coal intact and sucks out gas instead. There are 5 CSG companies sinking thousands of wells like this across the countryside. Arrow Energy is one of them.
We do what coal miners do themselves when they're underground coal miners. They have to drain the gas out of their coal to be able to mine it safely. And effectively we're doing that and making a business out of that ourselves.
Over the last 10 years, CSG production has increased by more than 100 times. Most of Queensland's gas supply now comes from coal seams. It's 98% pure methane that builds up naturally in cracks and pores inside the coal. The methane is trapped under pressure from hundreds of metres of rock and groundwater lying on top.
Basically, we drill a hole. This well here is to 300 metres.
On the way down, the well is cased to stop leakage from aquifers it might drill through. At the coal seam, a cavity is reamed out with a rotating blade and lined with a perforated casing. A rotating screw pumps groundwater out of the seam and up to the surface.
So this is going 300 metres down to the coal seam and bringing the water up from there?
Yeah, we set the pump a little bit below the coal seam so the gas water can flow out and come to surface.
Releasing the water pressure releases the gas, so the rate water is removed controls the flow of gas.
Water comes out via this top tubing here, and the bottom tubing here is where the gas comes to surface.
Gas from 150 of these wells is compressed and piped to the nearby Braemar power station, where it's burned in giant jet engines.
These are open cycle gas turbines, and they're particularly good for being able to turn on and turn off relatively quick duration so that you can match the peak demand in the electricity market.
This 450 megawatt station powers about 150,000 homes.
We think that it's climate friendly in the sense that the emissions from this are half of from a coal power station.
While the gas is cleaner, there's a catch. At full production, this company alone will produce 50 million litres of water every day.
The coal seam gas companies have got one big problem: what to do with all that water and the salt that's in it.
Up to now, the solution has been to leave it on the surface in massive evaporation ponds.
Can I taste this water?
You can, yes.
What's it supposed to taste like?
Slightly brackish.
Yeah, fairly brackish, I'd say. How salty is that?
It's roughly, depending on the fields that it comes from, it's roughly 1,500 ppm through to about 8,500 ppm.
That's about 1/6 the salinity of seawater.
We're looking at treating the water to make sure that we minimise the impact of the water, particularly the salt, that will be left behind on the landscape.
It's not surprising that here, on the fertile soils at the top of the Murray-Darling Basin, farmers are sensitive about salinity.
Now we're seeing these gas companies bringing up millions of tonnes of salt, storing it on the surface, and the government hasn't got a plan for it. It's just, oh, we'll put it in this storage and we'll bury it and forget about it. Well, salt doesn't go away. It's there forever.
But what if you could leave the salt, the water and the coal where they are and extract more energy by converting the coal to gas underground? That's the promise of UCG. There are 3 pilot projects in Queensland. Carbon energy is one of them.
UCG is very different from coal seam gas. Underground coal gasification extracts the energy in the coal itself, which means we can extract a very large amount of energy from a small footprint. In fact, 20 times the amount of energy you would do from a similar coal seam gas extraction process.
I've come to this paddock near Dalby because Carbon Energy is trialling its UCG technology here. Rain, hail or shine, 24 hours a day for 100 days.
It doesn't look like much, but I'm standing in the middle of a coal mine, one of the only ones of its kind in the world. 200 metres beneath my feet is a coal seam that's 30 metres wide, 8 metres deep and runs for 600 metres down that way, where it's extracted at this end through these pipelines after the coal has been converted into gas.
What's the pressure down there?
It's 17.9, George.
Okay, I've got a 7.5 and it's steady as well, so we're probably okay.
John Wedgwood heads the team putting this underground reactor through its paces.
I've got this flare going now. I'm going to open it up a bit more so you might get some drops in pressure.
How on earth do you get the coal burning in the first place?
This is the match. This is triethylborane. What we do is it ignites when it's exposed to air.
Here's how it works. It all happens underground, beneath the water table. The coal seam is ignited, and under high temperature and pressure, the coal reacts with oxygen and water to become a mixture of gases. The reaction is controlled by injecting more air and steam, so about a metre of coal seam is consumed each day. The resulting gas is sucked out through another pipe. UCG marries the mechanics of longwall mining with the chemistry of gasification.
It's very similar to longwall mining, except instead of having a machine underground, there's a chemical reaction on the face. And by putting the hot gases across the coal face, the coal effectively dissolves in front of your eyes and turns into this energy-containing gas.
The gas is called syngas, a flammable mixture of hydrogen and carbon monoxide. Every day, underneath this paddock, 150,000 tonnes of coal is being turned into gas.
It produces enough energy to run about 2,000 to 3,000 homes per annum if it were converted to electricity.
Injecting different mixes of steam and oxygen creates different hydrocarbons, making their underground reactor more like a chemical refinery than a power station.
To ensure that none of those chemicals escape out into the groundwater, we always keep the pressure a little bit below the pressure of the groundwater.
So if people say you're setting the earth on fire, how do you respond?
You just explain that you're setting the earth on fire 200 metres below a large wall of water, that the minute you stop breathing air on it, it will go out.